known from Herschel's map that the stars that we see in the night sky are distributed in a kind of disc shape. But when we look in more detail, we see a lot more structure there as well. We see these clusters of stars, of very, very bright, of many different colours, all very close together, often surrounded by some kind of clouds of gas. Maybe this is indicative of some kind of evolution taking place in the universe. Could these be young stars which are being born out of this gas? These processes are too slow for us to actually follow the process through. But there are other indications as well. We also see other clusters of stars, which are all a similar dim orange colour, gravitationally bound, no evidence of any gas. Maybe these are older stars nearing the end of their lives. Perhaps even more intriguing for astronomers a century ago were the so-called spiral nebulae. Some of these also appeared to have stars embedded within them, but they also rather resembled the star map that Herschel had come up with, these disks of stars. And so this triggered a great debate about what the spiral nebulae actually were. Were these other clusters of stars within the stars that we see, within this disk that Herschel had described? Or were these spiral nebulae actually island universes, other groups of stars, other galaxies beyond our own galaxy, the Milky Way? Since this question of whether the spiral nebulae were intrinsic to our galaxy or whether they were beyond our galaxy, much further away as island universes, was one of the biggest debates in astronomy at the time, many astronomers began to devise observations to gather evidence to support one side of the debate or the other. Many of these observations turned out to be correct. For example, it was discovered that many of these spiral nebulae had incredibly high velocities. They were moving towards us or away from us much, much faster than any velocity which had been determined for an individual star. So this suggested that maybe they were much further away. On the other hand, other astronomers claimed that they could actually see motion within these spiral nebulae. They were spinning around on their own axis. And what this would mean, were it true, would be that they would have to be within our own galaxy. If they were very far beyond our own galaxy, the outer edges would be travelling faster than the speed of light, which didn't obey the laws of physics as they were understood at that time. Eventually, this long-running debate was resolved conclusively by an astronomer named Edwin Hubble. He used the most powerful telescope of the time to study carefully one of the largest of these spiral nebulae, known as Andromeda Galaxy. He observed it night after night, hoping that there would be something that would happen which would give away the distance to this galaxy. Eventually, he hit the jackpot. He was able to detect a Cepheid variable within the Andromeda Galaxy. He was therefore able to use the law determined by Henrietta Swan-Leavitt herself to determine the distance to the galaxy. And the answer was very clearly in favour of this being a distant island universe. It was well beyond the confines of our own galaxy. And so overnight, our understanding of how large the universe was increased by factors of 10. So the infamous spinning spirals, which so strongly suggested that these spiral nebulae were within our own galaxy, well, it seems that that was just down to experimental error, in spite of many astronomers claiming to have made independent discoveries of this fact. So this just goes to show that although in hindsight it may seem obvious how we reach the conclusions that we do in science, at the time when there's conflicting evidence, it can take a very long time before these questions are resolved.